All right, so I think I double checked. I think it's chapter 6. Is that right? 7. Dang it. 6 was method. 6 was object. 7. Okay, so chapter 7 is going to talk about arrays. So, you know, what we can talk about is that, right, an array is this group of things that you can index, right? You can loop over. All of the elements inside the array have to be the same type, right? So we can have an array of any of our normal types. So what are our types? Double. Short. Int. String. Float. Boolean. Oh, all right. Character, right? We could have an array of, that's like a string. Oh my God, okay. Right, so we could have array of characters, which is a string. All right, so we have all of these different types that we can store in arrays. And actually, do you see a pair of brackets anywhere in this? I just made a main. Oh, look, we have an array of strings, right? So these are the arguments that you pass to a program. Now, we have never had to pass arguments to a program, but we could. And I'll show you how to do it in Eclipse, which is a little bit different than how you do something on the command line. And I'll show you guys that here in a second. So, all right, so we're going to write a loop to go through and print off all the arguments that are given to our program. So this is an array, and each index points to a bunch of characters, which is an array of characters. Right? So we'd have an array pointing to an array, and when you get into upper level classes, you'll learn about those and you'll hate them. And then I'll say you need to have a pointer to a pointer to a pointer, and then your head will just go, right, and you'll say, I don't like that, Dr. Miller. So, which is what my students say. But that's the way computers are, right? Sometimes they are complex. So we have this, right? If we have this is an object, which is something that we have methods on. So, oh, look, we have this magical thing called length, right? So in Java, arrays know how long they are. This is one of the properties of them. This is again, if you take upper level classes, you'll learn about things like C, and C does not have lengths of arrays, and all of a sudden we get things that crash, and then we have security problems, and the world is bad. So here we have the ability to say, well, I want to know how long my set of arguments are, right? So I can say, while I is less than length, right? So if length is 2, I have 2 things in it, right? So if I start at 0, I need to go 0 and 1, right? I don't want to go to 2, so that's why we say less than. And then we'll increment I each time. And so let's just print off our arguments, right? That's all we need to do here. Argument, and then I'll put a %d, and I'll put it in little brackets so we can see that it's kind of a bracketed thing. And anybody know the formatter for a string? String starts with the letter S. There we go. Okay. All right, so args is the name of our array, but how do we get something at index 0? Very specific example. How do we get the thing at index 0? What do I need to use?
Use
the brackets. So if I wanted to get the thing at index 0, right, I put a 0 in it, which is what I asked, right? So bracket 0. But I is going from 0 to the length, right? So I can use I inside of there. So let's see if there is anything that prints off when we run this. Nope, we didn't give it any arguments. Okay. Well, how do we give it arguments? Well, each ID is a little bit different. So in Eclipse, I can go to Run Configurations, and it's got this thing called arguments. Oh, great. So here's one called A, there's one called B, this one's called C, this one's called dog, elephant, All right, so I can list the arguments inside of this program arguments thing. So what do you think it's going to print off? What do you guys think arg0 is? Just guess. You have no idea. So you can be wrong, and it's okay. A is the first one, you think. Anybody have any different guesses?
Maybe all of them.
All of them, right? Who knows? Let's run it. Oh! I forgot to give it I. Oops. There we go. All right, so it does. So when we talk about running a program, it actually uses the space character in order to separate those arguments. Right, so everything that has a space in between it is a different argument. Now, that's when we're running it from within a program. Let me see if I can find the, well, I don't want to do this one. I'll do a different one. So how many of you have ever used a terminal? A few. The front row is my representing. Anybody beyond the front row used a terminal before? No. Okay. So what is a terminal? You've used it. Do you know what it is?
Same thing as a console, right? Like CD.
A console. Yeah, that's another name for it. Check IP. Okay, that's one thing you can do in it. But what does it do? You want to take a guess? Runs commands. So a terminal is the sort of original way that we interacted with computers, right? Computers are doing things at like a circuit level where we have transistors and resistors and diodes and inverters and all of these sort of low-level electrical things, and we want them to do stuff that like makes sense to humans. So the original sort of interfaces, you can think of DOS, right? So DOS was one of those, where it would allow you to interact with the hardware, right? And we have this thing called the operating system. Anybody, what are the operating systems out there? Any guesses? iOS. Windows. Android. Linux. There's lots of flavors of Linux, right? Any others? Is that it? There's BSD. That's another one. We've got, let me see. Mac runs a version of BSD called Darwin, right? So the evolution of BSD, thus the Darwin. We've got a variety of, Raspberry Pi has their own OS for theirs, which is based on Linux, but it's running on ARM. So we have a lot of different operating systems, and each operating system allows the user to interact with it in a different way, right? When you're on your iPhone, right, it's completely touch, right? Everything you do is touch except for maybe the home button, and there's probably another button on an iPhone, I don't know, right? There might be some other button. An off button? Is there a volume button? Yes, a volume button, right? Right, allows you to change the volume. So this is a way at the very lowest level to interact with the operating system. So there's lots of commands that I can run. These will differ a little bit if you're on Windows and running cmd.exe. It has different commands, like I always type ls to list the files, whereas on Windows it's like dir, which I can never remember, so I always type ls and it says that's not a thing, and then I type dir and I remember. Right, so ls will list me all of my files that are here. Now ls, by default, is just showing me all of the files that they exist, and the colors mean things. So in this, the colors, black is a file, blue is a directory, and I think that orange or whatever that is, what color is that?
It's highlighted. You can just say highlighted.
The highlighted ones are, I think, symbolic links or something like that. But when I ran the command, I just said ls. Now, I can give it different arguments. ls minus h means put things in human readable, which didn't change anything. Now, list all files. Okay, so there are actually files which their names start with a dot, which are hidden by default. Right, so every Mac OS X user has these hidden files like .ds store, which is stores information about the indexing of all the files in the file system. Right? We've got all kinds of things like my bash rc, which is how bash runs. And these are all hidden. So when you normally go into the Finder, you don't see these. But I could change how the program worked by giving it an extra argument. And so arguments allow us to change how a program works. I like HAL, H-A-L, which shows me all of the files that are in my file system, plus these magical things called permissions. So permissions say, what are you allowed to do with this file? And so we've got, if you look on the left-hand side, you're going to see 4 different letters, right? We see a D. What do you think D stands for? Directory. We got R, W, and X. So what do you think R stands for? Read. W. Right. X. Xylophone. No. Execute. Right? So execute. Now there are actually pairs of 3 of these, right? So there's one, there's another, there's another. So those groups of 3 are for the different groups, right? So the first one is user, right? So that is specifically for a particular user, right? So a user has the ability to change all the permissions on their own file if they want to, right? So that's user. The second one is group. You can see that my group, which I think the default on OS 10 is maybe staff, right? So that's the permissions of anybody in the group, right? So you can have more than one person in a group. And then the last one is called other. So other is anybody who's not a user or not in the group that this file belongs to, that's their permissions. So we got user, group, and other. Right? So these are the basic permissions. And then you can see this first column is the user. And the second one is the staff. And, well, I guess I have weird things on my computer, but. So this I actually ran as root, so the user is root. And this was actually a packet capture, or capturing the network traffic produced by a network-connected Barbie doll, thus the name Barbie.pcap. So I got all kinds of interesting things, which by default looks like my pcaps are all that way. So those are the arguments that I can give to a program, and that allows us to, again, change how the program works. So, right, that's the entire point of why do we have these string array args? Because every single program that we write, we can give it arguments so that it behaves a little bit differently. So that's one use of an array that you already sort of had, but didn't really know you had. Right? So we've got that, which does awesome stuff. But let's try and do some actual work with some arrays. So you guys are the experts. You read chapter 7 clearly, because that's what it's called. So so here's the problem that I want to try and solve. So Dr. Miller likes to sit in his car and think about the world, and he thinks to himself, man, I wonder how many miles per gallon my Toyota gets. He says, well, how could I solve that problem, figuring out how many miles per gallon my Toyota gets? Does anybody monitor this on their own? You got a few people. So how do you do it?
You fill your tank up all the way, and then you drive a certain amount, and you keep track of that amount, and then when you fill up again, you see how much gas you put in.
Okay, yeah. So if you fill up to the top every single time, right? You don't like do the I'm going to put in $10 worth of gas, right? Because then that like messes your whole thing up, right? So if you always fill up to the top and then you mark either using your trip, right, on your odometer, or you just keep track of mileage before, mileage after, right? And then in between, right, that's how many miles you drove, and you know how many gallons you put in, and so then you can figure out, well, how many miles per gallon did I have? So let's suppose that somebody wanted to read in this information, right? Let's suppose we're going to read in 17, right? 17 of these things. Well, 17's high. Let's go with 7, because I'm going to have to type all these. All right, so I want to figure out given 7 different trips, like what my MPG was for each one of those trips. So what information do I need to store? Anybody? Okay, so let's suppose we don't have a trip. We just have odometer, right?
Oh, so you mean like if you're at 93,000 for the first trip, second trip you're at 93,000.
The next time I fill up, yeah, I'm at 93,300, right? Yes. So that would be that's one input. What's our other one? Gallons. Okay. So does anybody have an odometer that like goes to the tenths? You do? Okay. Our odometers go to the tenths. Mine doesn't. Mine's digital and yet it doesn't go to the tenths. So go figure. Okay, so what type of variable do we need to store something that has decimal places? Double or float. Let's click double. We want to be twice as precise. Okay. And I want to make this an array, so what do I need to do? Brackets. What am I going to call this? Oh man, you guys are odometer. Okay. Odometer. I probably spelled it wrong. Does anybody know? Probably. Is that right? Did I get it right? Probably not. Okay. So how do I make this be an array that can hold 7 things? There's a magical word that I need to put in there. Or 2.
You could go around that and just use the curly bracket.
Well, but that means I don't know. But I want the user to like enter each thing. Yeah, we don't want to do that. We want to say it holds 7 things. What was the syntax? To make a new array that holds 7 things.
Double, sorry.
Okay.
Bracket.
7, right? Okay, so 7, oh, this is 7. It's gonna like pop up a whole bunch of times. And I just don't want to remember like where I put it. So as I'm going, right, I'm gonna make another array that's gonna have size 7, and then I'm gonna write a loop that goes 7 times. So what I'd actually like is an integer to say, okay, every time that I'm going to reference the number 7 in my program, I'm going to use max. Now the benefit of this is, let's say I use the number 7 150 times, right? And then my wife says, well, Matt, we just drove somewhere, so now it's 8, right? So now I got to go and 150 times, I have to find the number 7, and I have to change it to the number 8. So that sucks, right? So I don't want to do that. So what I'm doing is I'm making what we call a constant, right? So something that is not changing throughout my program. It's the maximum number of things that I want to do. And then everywhere that I use that, I will just use my constant instead of this. And I think, yeah, I can make it final. So final means that you are not allowed to assign this some other value, right? So if you accidentally say, oh, max equals 9, it's going to give you a compile error saying, oh yeah, by the way, you told me you don't want to change this ever, right? You assign it one value ever, and then it's done. So if we do put the keyword final, that means I can't assign it to something else. So I can't mess it up, which is the nice thing about the the compiler. It tells you when you mess something up some of the times. All right, so now we've got the ability to store what our odometer says. Now we need this other thing to hold what?
The gallons of gas.
There we go. And clearly, if you ever look at the gas pump, like every single one of them goes to 3 decimal places, because why would you not want to look at hundredths of a, I don't even know what a hundredth of a gallon is. It's gotta be nothing, right? But they keep track of it because clearly they want to charge you. That's why the gas price is, $2.29 and 9 hundredths. Okay, so we will use doubles. Right, double array. And let's call this one gallons o gas. Clearly, is it not going to let me put dashes? Oh, you stupid program. Okay, I'll put underscores since you don't like that. And I'll try and spell double correctly. Okay. So I got my gallons of gas and I got my odometer readings. Okay. So now I need to get these from the user. Oh man. Let's see, which one was that in? Is it in methods? Hey. Okay. Well, that's not the one. Maybe it was that one. That one. Ah. There we go. This is close. It returns integers. We don't want integers, do we? We want doubles. So we'll call this one get double. Okay, so it's going to return a double. Well, let me save it. It's going to freak out because, well, it didn't freak out because an integer is always a double, right? You can convert from one to the other. But what we really need here is this needs to be a double. And then we don't say integer.parseInt, we want double.parse double. And then our logic is all the same, right? So I'm just taking what we've already done and saying, well, let's make sure we get a input from the user such that it's not broken, right? So now I need to ask the user for all of these things, and they need to enter 7 of them. So what? Let's just do one. Let's see how this works. Odometer. So if I want to get the first thing in my array, what do our indexes start at? 0. So odometer bracket 0 equals. Okay, now I gotta call my method. So how do I call my method? Get double, if I can spell. Oh, I need a keyboard. Gotta make one of those. Shh, there's no misspellings there. As long as I use the same word over and over again, it can be keyboard, not keyboard. Okay, so we want to ask them what? What are we reading? Enter the odometer value. Okay, so that'll read our odometer. And then what else do we need to read? Clearly. Now I can type gallons. Oh, yes. Sweet. But I don't want to save it in my odometer, right? I want to save it in my gallons of gas. Great, we got the first one. Now we need to get the second one. How are we going to do that? Any suggestions?
I mean, we could keep doing this.
We could keep doing this all day, right? Is that what we want to do? Do we want to type this 7 times? No, we don't. So what could we use that we have the ability to do that would like repeat this same thing over again, except go from index 0 to index 1 to index 2. Use a for loop. Okay, so for int I equal to 0, I is less than max. What do we do with I each time? I plus plus. But then I'm always reading the thing at 0, so I need to assign odometer bracket I, matey. All right, so now we will read all of those in. Oh, perfect. Now we can calculate the miles per gallon, right? And what type of value will that give us? Any guesses? How do we figure it out? We take what? You're smiling. You know the answer. Miles divided by gallons. So double divided by double equals straight. Double, right? But we need somewhere to store it. And we're going to have like 6 of them, right? Because the first one don't count. You can't figure the first one out. Let's say we want to store another 7 of them. So what do we need to do? Any suggestions? Drew, you got a suggestion? Make an array. What should we call it? Your choice. You can call it anything you want.
Miles per gallon.
You picked the lame one. Miles per gallon. You could have called it, Drew or Halloween or, there's any of those. That's okay. That's a logical one, right? That's a logical name you can call it. Boogers, right? That's another name you could call it. All right. So we need to go and figure out. Let's do one of them. Okay. So if I'm looking at, so I have my miles and my gallons. We'll just have I'm bad at math, right? Computers are a lot better at it. So let's say our odometer says 100. Our gallons of gas was 7. Then our odometer says 200, and our gallons of gas was, let's not use 10. We'll do 5. I can do that much. It's pretty good. Probably pretty good gas mileage. Okay, so if we want to figure out for the second row, right? So index 1, this is index 0. So we got miles, gallon, I can't spell, and then MPG. So what is the MPG for this? How do I figure that out? You got a guess? We don't divide 200 by 5, so what is the number of miles we drove?
Oh, 100.
Because we take 200 minus 100, right? So we take the odometer at index what? 1. I saw a 1 back there, right? And I subtract what? Excuse me. Okay. Odometer. Bracket 0. And I take that all and I divide it by gallons of gas. Now I'm regretting typing all that. Gallons of gas. Bracket what? 1, right? Because that's the actual number of gallons I used for that time period. All right, so our miles per gallon at index, right? So we're going to do it at index 1 is equal to odometer bracket 1 minus odometer bracket 0 divided by gallons of gas bracket 1. Perfect. So I figured out the first one. Let me do the second one. Miles per gallon of 2 is going to equal odometer of 2, right, minus odometer at 1 divided by Fallon's, Jimmy Fallon's, right? Gallons of gas bracket 2. Okay, I got 2 done. Oh, let's see, I got 6 more to go. All right, perfect. Or should I do something different? Okay, see, my son has a shirt that says I laugh at dad jokes, so clearly I'm bad at dad jokes and computer science jokes. All right, so what we actually want to do, we don't want to start at 0, right, because we can't actually do the calculation on thing 0. So we're going to start at 1. So for int I equal to 1, I is less than, what's the maximum? It is 7, but it's called max, right? I plus plus. Now we're going to have to get a little tricky here. All right, so the miles per gallon we're looking at is at I. The odometer is at I. The previous odometer is what? I minus 1. A little bit tricky, not too much tricky, but a little bit tricky. And the gallons of gas is I, right? Now if I started at 0, right, it would actually crash, right, because it would try to go to index -1, which is not a thing, right? We don't have negative indexes in here. So I needed to start at 1, right, and that's how I can do my calculations. So now we need to go and print off all of our information. So let's do a thing that would go 7 times. Oh, lame jokes by Dr. Miller. A loop that goes 7 times, and we're going to print off the miles, the gallons, and the MPG. And let me print a header first. So we're going to print off miles. I'll put a tab in there. Gallons. Another tab. Oh, gallons. And MPG. Okay. And then I want to, we'll use printf. So we're going to print off the miles, which is a double. And what's our formatter for double? F? LF maybe? I think for double. Okay, and then %LF. I wanted a tab there. So I print off 3 floats, and my floats are the odometer at index I, the gallons of gas at index I, and the miles per gallon at index I. Oh, and I need a new line because it's printf. This means I'm going to have to type these all in. Oh. Okay. So, miles 100, gallons 7, miles 200, gallons 5, 4. Oh, let's see, 400, 10. Yeah, I was really pushing the pedal down there. 500, 5, 600. No, I did all that typing and I messed it up. Is it just %F? Oh, man. Not LF. I don't have to do that again. Oh, it stinks. What time is class done? 55. Oh, I got time. Don't leave. We're not done yet. Oh, now I gotta try it again. Okay, so let's go 0. I use 10. 200. 350. All right. So we went. Well, my tabs didn't work quite as well as I had envisioned. We got lots of decimals after that, so clearly should have fixed that, right? But I went. See, 0 to 100, so I went 100 miles, and I got the number 100. Well, that don't seem right. That's not the right value. Anybody know what we did wrong? Parentheses. Oh, right. Order of operations. Right. Division comes before subtraction. Ah! Okay. Also, another interesting thing is that it printed off the miles per gallon for that first tank, which really didn't do us any good, right? So I'm going to say, well, if I is 0, then I don't want to print that last thing, which is clearly not right. So if I is not equal to 0, do what I'm already doing. Otherwise, if I is 0, I want to print off only the first couple things, right? Because that other one doesn't make any sense. So might as well get rid of that. And then how do I make my numbers so that they only have, let's say, 2 decimals? Anybody remember? Point. We can do the O, 0.2. Let's do 3, right? Because lots of, well, I guess the odometer, right, are usually tenths, right? So that's one place. And then this might be 0.3. And the last one will go to 3 decimal places, probably because of math. It says that I should, right? And I don't like typing, and clearly 7 was way too many, so we'll do 3. Hey, look, I only had to change it once. Amazing. All right, let's get this done. So 110, 200, 5, 300, 10. Ah! Did I do that wrong? Do we not get? What did we do wrong there? Do I need to do this? Urgh. I thought I'm old. I can't remember anything. Let's try this again. See if that worked. There we go. Hey, it printed off nice, right? So we went 100 miles in the second one. We had 5 gallons. That means we got 20 mpg. All right, we went another 100 miles. We used 4 gallons. That means we got 25 mpg. Okay? Any questions on this? All right. Well, we'll do more examples next time. So come again. We'll have news stories. That'll be fun.